different. We'll be doing a puzzle. And the last time I streamed, I actually kind of wanted to do this, but I haven't really got myself to do it yet. And today, let's try to solve it. The Minesweeper puzzle by Euler Zach. Okay, I hope you can see my screen. Personally haven't done this puzzle before, but oh, you see, everyone I know doesn't. Oh no! Wow, this might be a tough one. Even Mr. Papaya couldn't solve it. Okay, but no worries. Let's try to see whether we can solve this puzzle. So this is a Minesweeper game. You have a board. You want to like click on a certain cell and then open up more and more of the cell, and you only want to click on stuff that preferably contains no mines at all. Because if you click on a mine, you're gonna lose the game. So let's see what we can do. Let's solve it. Okay, so this is the gameplay loop. So while true for I in range 16 for cell in this. Okay, row plus equals to cell. Okay, print row. Okay, so what is the input here? Grid is 30 by 16, 99 mines. Okay, top left corner is 00. Single test case that is randomly generated after first action. Due to randomness, you may have to submit multiple times to solve the puzzle. Okay. Minesweeper is inherently a random kind of program because you may not be able to solve the program all the time. Question mark for unknown dot for rebuild cell 1 to 8 for rebuild cell with corresponding number of mines. Okay, we have single line XY. I guess we should import numpy. Okay, let's import numpy. Okay, so 1 to 8 for rebuild cell with the number of mines. Okay, maybe what we want to do is we want to have a grid equals to mp.array. Mm, I want it to be a string, I think. Yeah. So, oh, but this one is by the object here. So maybe we need to have numpy.empty with a shape. And the shape here will be 30, 16, 30, because there's like 16 rows and 30 cells. So yeah, 16, 30 would be good. Okay, yeah, 16, 30 would be good. And then over here, what we'll do is we'll have. Actually, is it necessary to use NumPy? Because actually, if I store it as a list of strings, that would work as well. Maybe we don't really need NumPy, but let's just put this away. Okay, so what I did now is I just look through all 16 rows. I add in the input to the grid. So the grid should contain like the list of 16 by 30. Okay, let's see what it prints out. So it prints out question mark, question mark, question mark. Okay, very good. So in order to like reference a certain cell, I can just put like that particular like zero, the index like grid 01 or something like that. Yeah, and I so now everything is question mark except. Let me just pause this for a while. So now everything is a question mark. Let me just expand this. Okay, so it's not very well displayed, but you can see that everything is a question mark here, except for this part here that is 2121. which corresponds to the one at the top. 21111. So all this here should be displayed as 211212111 and so on. Okay, so I do need a way to index my grid. Okay, so that I know what are my adjacent cells. So like over here, you see this is 2. So it means that this is 2. 1 means this is 1. 2 means this are 2. 1 means this is 3 here. 2 is like that, 1, 2, 3, 4, 5. So is there a way to solve this thing? So like if we know that there's 1 within this tree here, it means that this tree itself contains 1. Or no, 1, 2, 3, 4. These 5 cells contain a 1. Oh, this can be tough because we need to solve multiple like linear equations in order to solve this. You think how to solve this? Yeah. So if let's say we already know that these are the numbers here, we can make a series of linear equations like 1, 2, 3. This A, B, C, D, E. These 5 cells, 2 mines are there. Within these 3 cells, 1 mine is there. So like over here, within these 3 cells, 1 mine is there. So within these 3 cells, 1 mine is there. Does that help to solve anything? Yeah. I guess in this case here, you still don't know anything about the mines, so you probably need to press something else in order to like solve it. Okay. Either way, let's just do a simple logic loop. Okay. So let's just store all possible combinations of guesses. Okay. So let's see how do we do that. So maybe we have a list of like logics. Maybe it's in the dictionary. So we want to see also which cells are not question marks. Okay, so we maybe keep a list of cells that has been opened before. So um, what I want to do is I just want to compare like what cells have been previously opened so that we don't like update the cells again because we don't need to do that. So we store in what cells has been opened before, and then the next iteration when we click another square we store what cells has been opened before. Then we try to store it into some like uh, in this dictionary called logic, and then we try to like basically reduce the amount of logical conclusions that could be made. If like two linear algebra statements overlap, then maybe we can deduce something about the over, or maybe if one is a subset of the other, then we can use the subsets information to change the big uh, group's information. Okay, I haven't really thought too much about it, but something like this. Let's say if cell A, B, C has 2 mines, and cell AB has 1 mine, then this necessarily means that we can eliminate AB from here, and then we can make C has 1. Then we know that C has a mine. So either A or B has a mine. So yeah, something like that. Not too sure how to do this yet, but if let's say we have something like that, we basically what do we do? Find all. So first up, step one, maybe step one. Let me just write this down. Step one. Okay, I'm gonna shift this a bit back here so that it's I'm not even sure whether I can solve it. Let's see whether we can do it. So step one will be to find out which cells are newly opened and add add it to logic array to logic dictionary. Or it can be an array actually. Yeah, we don't need a dictionary. Logic add it to logic array. Okay, then step two, look through logic array. Okay, add new logic if um, a certain cell has been denoted 1 or 0. Okay, so basically this step will be to like look through logic array, remove elements in logic array if a certain cell has been already denoted as 1 or 0. So if you already know the identity of this, okay, then it's like we can, like for example, we have a b c as 2, and then you know that like a b is 1, or rather if you know like a is 1, then what we can do is we can then say that okay, b and c is now 1. Yeah, we can remove away a because like a has already been uh marked as safe, or marked as okay. So basically then after that, step 3, find out which cells are safe and add to playlist. Step 4, find out which cells are dangerous and add to, actually this one we add to not playlist, yeah, because we don't want to play those cells that are dangerous, so we probably need to flag them. Yeah, okay, so maybe in this part here, next one will be to look through logic array, and then what do we want to do? Look through the logic array and find out which, if there is a subset, then basically if there's a subset of another, okay, then we remove subset from the main set and form another logic. So that will be what I wrote down here like this: a b c is 2, a b is 1. That means necessarily c is 1, so we can do something like that. Yeah, so something like this. So yeah, let me just, yeah, so something like that. And then maybe step 6, if there is an element into playlist, play the first one, okay, otherwise randomly pick an unopened cell which is not in not playlist. Yeah, I think that sounds fair. Yeah, that sounds fair. We probably don't want to pick the corners, so I'm not too sure about that, but let's just try this, see whether it works first. Okay, this is a medium puzzle, so probably doesn't need to think too much about it. Okay, let's try. Find out which cells are newly open and add it to the logic array. So let's see. We have a has open here. So this one is to tell us which cells have been opened before. Okay, so what we will do is we'll look through the entire grid here. Okay, so maybe we have another one newly open, or basically like open. Okay, and then basically like this. Okay, maybe I do here. So this part here will be just to get in the input. Okay, and we don't need to print this anymore. I think I'm quite confident about the input. So what we want to do is we want to find out which cells are newly open, right? So let's do that now. So newly open, or maybe we just call it open. So okay, let's just define a new thing. So get index ij, return I or row column. It's just basically going to be return row times 30, because the grid size is 30 plus column. Yeah, so this just basically just returns the index of a cell from 2D to 1D. Yeah, so we just return the value from a 2D value to a 1D value, and that's what we do here. Row times 30 plus column, because there's 30 cells across. Okay, so step one, find out which cells are newly open, add it to the logic array. Okay, let's just look through the grid then for I in range 16. For in fact, we can just quite row and column, make it easier for column in range 30. Okay, then we just look through. This is a O 16 times 30 operation. I think it's quite little for modern day standards. Okay, so it should be fine. How long do I have? 50 milli. Yeah, that should be fine. Yeah, that should be fine. Okay, so we have a grid. Okay, so our grid row column. Okay, if the grid row column, okay, not basically if it's open, okay, then what we'll do is we'll add this to the open array. Open dot append get index row column. So we append this number inside. Yeah. So maybe we do a define one, like returns the row and column a cell from 1D to 2D. Return index divided by 30, which is the row, and index percent 30, like that. Yeah. So one is get index, one is get pos. Index, or maybe we just put like from index, get index and from index. Okay, that sounds good. These two helper functions. Okay. So just put here as helper functions, and then down here will be like the main program. Okay, so we have defined this. Step one, find out which cells are newly open, add it to the logic array. So for row in this, for column in this, if the grid row column is not unknown, it means that it has been opened before. And then we append this to our open array. Okay, so far looks good. Okay, so we have this get index, which gives us the index. In fact, maybe I can just omit the index here and just store it as a tuple, because this can store tuples as well. Yeah, I mean, yeah, we can just store it as a tuple, right? Then we don't need this. Oh wells. Okay, so we can just store this as a tuple in open. Okay, so then we have this has open, right? So maybe just put newly open is this. If row column not in has open, okay, then what we'll do is has open will append this, and newly open will also append this. Yeah, so basically has open will be updated by this new cell, and then newly open will be here. So what we want to do is, now let's just see that it works. So I'm just going to do this print, okay, has open, and then this one will be like print has open file equals sys.standard error, and then we also print newly open file equals sys.standard error, and then we just try it out and see. Oops, I missed out a bracket. Try this out and see whether it has stored our newly open and our has open file successfully. Let's try. Invalid syntax, not a function on line 63. Okay, that's because I missed out a bracket here, right? Okay, so this will actually take some time here to check this. But I hope Python does like binary search or something so that it will be faster. Okay, let's see what what this will be. Okay, so in order to check the whether it has done correctly, we can just check the first game state. So newly open is this 0103. That's a lot of cells. Are you sure that's correct? Okay, something's wrong here. Okay, so we open this one here. 0103. This one all not supposed to happen. Okay, 0103. Yes, so these are newly open. So the newly open is correct, but it seems like it's storing all the. So weird. Oops. Yeah, it's very weird because you're not supposed to store so many cells unless there's something wrong with my grid. Yeah. Oh, I know why. Because I need to do. Oh, I still need to do my input dot split. Okay, so because there's spaces. Okay, I need to do what I did just now. So let's do this. So we add this inside here, and then we just add the row inside the grid like that. Okay, so let's play the test case. So we only supposed to get some cells open, not everything. So okay, string index out of range in line 37. Oh, okay, this grid supposed to be here. Because we do the row that we append it. Now the grid is. Or we don't have to do this also. You can just replace all of the cells by a space. Replace all the space by a null space or by an empty character. Okay, what is happening now? Oh, there it goes. There it goes. I think it's working now. So just wait for the thing to load. Okay, it's taking a while. Yeah, I think it should be fine. I think it should be fine. Let's just wait a while, see whether it loads correctly. Uh, there is. Okay, so you can see that in the beginning, like number two opens up this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh, that's still a lot. Is there like 16 cells that open? Yeah, yeah, yeah. Okay, so this looks correct. Like 19 comma 8 should be that. Okay, pause. So we should have like this one here. Oh, this is 5 comma 19, so we should have 5 comma 19 inside here as our newly open cell. So you should have 5 comma 19. Very good. 5 comma 20, 5 comma 21, because it's row 5 column 21. 6 comma 16, 6 comma 17 until 6 comma 22. Do we have that? Yes. 7 comma 16 to 7 comma 22. Yes. 8 comma 16 to 8 comma 23. Yes, we have that. 9 comma 17 to 9 comma 23. Yes. 10 comma 20 to 10 comma 23. Yes. And then lastly, we have 11 comma 21 to 11 comma 23. Okay, good. So the newly open should be exactly the same for the beginning, but after that, newly open should be blank because we didn't open anything else. So let's just check. So yeah, so at the beginning, newly open did indeed match all this. So that's great. Okay, it means that this function is correct. Let's see whether we can. It's a little laggy. Unfortunately, it's a little laggy for a while. Okay, question mark for an unknown cell. Okay, so we have got this already. Okay, next we need to. Oh, I forgot to do one. We need to add this to the logic array. So actually, we may not need newly open after all. All we need to do is to just add it to logic array. So okay, how do you want to structure our logic array? We need something like this, and this. So it could be like tuple. We could store it as a tuple. All these elements here, and then this. So maybe what we will do is we will get logic. Let's have a function called get logic, and then we get the logic of the row and column. Okay, so the get logic will return like query value maybe. Okay, so we have a get logic function here. Okay, so maybe what we'll do is we will maybe do a zero padding of the input so that it will be, yeah, we'll do a zero padding so that we don't have to do edge cases. So what we'll do is we'll do like this. The zero padding will be with a dot. Okay, because we want to have the edge revealed. So what we'll do is like this, dot times 32. Okay, and then for I in range 16, okay, actually this doesn't matter. Grid plus equals to plus this, and then at the end of it, grid plus equals to this one. Okay, so this will do some zero padding to the grid. So what we'll do now is instead of doing like this row and column, we do 1 comma 17 and 1 comma 31. Okay, so that basically what will happen is that we basically like do some form of padding whereby we put like dots at the edges. This will help us to do this get logic function more easily. Okay, so let's do the get logic function now. Find get logic row column. Okay, this takes in the row and column values and outputs query list of non dot cells, list of non dots, and actually it should be list of question mark cells, because if it's like a dot or 1 to 8, it means there's no mines there, right? Around the row and column, around the target cell. And the value will be the number of mines as indicated by the target cell. Okay, so if let's say the row and column itself is, if let's say the cell itself is a dot, we don't have to do this. So we can continue this. Okay, we don't have to, no need to append the logic of a cell with no surrounding mines. Okay, after we do this part for those with mines. Okay, so we take the grid itself. Okay, so we take the grid row column. So what we'll do is we'll just basically append the number of question mark cells, num possible mines. Okay, maybe what we do is like num mines equals to ints grid row column, and then num query if the okay, so we need to do a loop for I in range 3, minus, for I in range -1 to 2 1. Okay, actually what we can do is like that. For I in -1 0 1, for j in -1 0 1. Okay, if the grid, okay, row plus I, column plus I, okay, if it's equals to a question mark, then what we do is we'll add that. So maybe we do need the index after all, because like we do want the index. Yeah, let's try about the index first. Okay, try about the index first. Maybe I just keep this. Maybe we still need this after all to like simplify our expression. Or we could have a list of tuples as the query. Not sure whether that will make it tougher, but let's just do without this indexing first. We see that we can do everything with tuples first. Query.append, okay, row plus I, column plus I. So this will be our index over here. So let's return now, return query and num mines. Okay, let's just, for sanity, we just print out the logic. Okay, let's see whether this works. So what we should do is we should have the logic whereby we get the value of the current cell, and then like the let's see what's the, so we do have a logic that will be appended, the logic array. So this is the logic array for 16, for 19. Okay, good. But it seems to me that like this 419 appeared three times in this loop before one 420 appeared. So this is obviously wrong. It probably means that over here this is written wrongly. So yeah. So these are basically the areas around the target cell itself, whether or not they contain question mark. So question mark is a potential mine. Okay, looks good. Okay, there's this thing here. The first one looks weird. Like, why is there a blank here and there's one? Okay, it probably means here or here, right? It's two. So 222, 222. It means this one actually. 222, 223, 224, 1. It's a little hard to follow because like it doesn't really match with this. So maybe let's make it match with the, yeah. Let's just go back to the original one, and then we basically just like add one here to just, so there's a lot of things added, right? We don't need this. What we really want is in the logic itself here, we just minus one from here. So okay, so it includes the target self itself, uh, which we don't want. Okay, so we don't want the 00 to be here because we don't want the target cell. Okay, let's try again. So we don't want the cell itself to be uh, given inside this query, but we want the surrounding 8 cells to be in the query. Okay, so let's take a look. I still like to see it like this actually because this tells me more about the position. Okay, so let's take a look at the game if we play it. Okay, wow, that's a big pot. Okay, 213, 214, 215 is given as a value 2. Okay, so let's see where's 213. 213 is this one, 213, 214, 215 is given as 2. That's correct, but it's actually missing out this one here, 313 as well. See, 213, 214, 215 is 2, but how about this 2 here? These are also part of the, so it appears that I've entered a wrong value here as well. Row plus I column plus J. Yeah, I keep typing I. So over here, um, yeah, that's just quite a silly mistake. Yeah, so let's see how this works on the new bot. So it should give us the query of the surrounding cells that have that particular value. Okay, so let's see. Okay, so here we have 419, 420, 421, 519 is 2. So let's see. 419, 420, 421, 519 is 2. That's correct. 420, 421, 422 is 1. Okay, that's correct as well. Next we have 421, 422, 423 is a 1. That's correct as well. Okay, 422, 423, 424 is a 2. Okay, looks correct so far. Let's just zoom to the last part. 822, 822, 822, 920, 921, 922 is a 1. Okay, this part here. That's correct as well. So it looks like we have captured all the queries well. Okay, that's a good first step. Okay, that's a good first step. It means we are about to solve it soon. Okay, let's go next to the next step that we need to do. So we need to look through the logic array and remove the element in the logic array if a certain cell has been denoted a 1 or 0. Okay, so very simple. For query value in logic, if length query equals to 1, okay, so what we want to do is we want to put like maybe what we have is like this. Mm, okay, what did I call myself? To play and not play, right? Okay, so on this logic is the list of query values for the potential possible mine positions. Okay, so we have all this here, this four over here. Now we go through the logic array. So for query value in logic, okay, because in our logic array we have query, which is this list, and the value, which is number of mines here. For query value in logic, if the length of your query is 1, it means that there's only one cell here. Okay, so if the value is 0, then what we do is we will add this to the to play, right? Like that. Okay. Okay, so if the cell is safe, then can play. Okay, so what we also want to do is we want to add this thing to the singleton list. So what we do is like if we have a singleton, it's like this, and then we also want to append cell to singleton list to remove all instances of them in logic array. So what we do is singleton, okay, dot append. Okay, what we append the query 0, which is the first element of our query. Okay, and yes, it's in the list, right? So we append our query, which is this tuple here, and then we will append the value as well. Okay, so for so we look through our logic array now. So for so our logic array is a list, so it should be modifiable like that. Okay, okay, for each in the singleton, if let's say the query, okay, so at the end of it, we still need to like okay, let me see how to do this well. Okay, for each query value in singleton, if query in the this thing here, query in log I 0, which is the first element here, then what we do is logic I 0 dot pop. So we can pop the by value. So we can pop by index or by value. So like over here, we can do a pop. I think it's called remove actually. Pop is by index. Okay, it looks like we can use the remove operator to remove by value. Like that. Remove Alice. Okay, so let's do the remove over here. So we remove the query from our this logic query here. Okay, and then not only that, we'll also subtract the value from the logic second part. Okay, minus equals to value. Okay, then finally, if okay, this is actually a little tricky. Okay, because this logic, if I pop this, it might affect the index when I run through it. So it will be better if let's say we just keep those. Okay, so if let's say the logic has length 0, we want to pop it. Okay, so okay, so what we do now is like that. If logic I wonder if I can just like enumerate over the logic and then pop it like that. Okay, let's just Google how to remove element from list while iterating. Okay, this is yeah, we can do something like that. Yeah, that might be better for Python. Yeah, let's do the list in. list comprehension method in order to remove an element while iterating over the loop. So we don't have to do it here. So what we can do is like that. Logic equals to, because it's very tricky. Even in C++, it's tricky also. Uh, keep only, but C++ at least you have pointers, so you know exactly what element it is. When you remove an item, you can subtract the pointer by 1, which means that we can actually adjust the pointer while we look through. But Python doesn't allow you to adjust the pointers while in the middle of a loop because it's all abstracted from the user. So we use the Pythonic method to do it. So in order to keep only the logic queries with length greater than 1. So what we do is logic equals to query value for query value in logic if, okay, length query greater equals to or greater than 0. Let's just do that. Is there something wrong here? Set item not defined on type unknown. Okay, what's the issue here? Okay, I did not, when I created this here, the value was a type unknown, is it? But it's an int over here, right? So maybe if I specify as int, it will solve the error. Will this work? Actually, this shouldn't actually matter. Let's just try and see whether it works. They should already know that this is a value. Hi, Money Guess. You can use delete item or list dot pop index to delete. Yes, but I want to delete while iterating over a loop. So it will be tough to do that in Python. Yeah, because when you delete something, it kind of affects the iterator. Tuple does not support item. Oh, I see the problem now. I have to assign a new tuple because this is given the form of a tuple. That's the problem. So we can remove the query in a list here, but it will not be assigned to the tuple. So let's, okay, so maybe what we do is like that. Or should we just like not use a tuple for this? We can just in the logic itself, we can append it as a list. Then we can save this. We can, because tuples are immutable in Python. Let's see whether if I change the logic to a list, whether it helps. And over here, we need to make it like a list as well. Maybe I should have used a dictionary. I mean, dictionary. Okay, tuple does not support line item assignment. Line 86. Try again. Okay, so now let's see whether it is kind of working. So yes, correct. So that's why we use a list comprehension here. Like over here, it's also mentioned at the top here that you have to use a while loop in order to um, like where's the while loop? Someone mentioned it's a while loop, but yeah, they gave a list comprehension solution here, which I thought was quite elegant. So I'm using this solution where we just keep the list. Or actually, in Python list, you can use something called filter. So we can also use the filter element. Yeah, the filter function and list actually, I think does the same as the enumeration method, list comprehension method. So we can do this. Like if you want to filter by something, so like that if score greater than equals 70, we can use the filter function, filter something based on your like what is given scores. So we can also do something like this. We can do the filter on this array and then we have our new filtered here. Yeah, but that would be the same as using a list comprehension actually. So I think a list comprehension would suffice for this. This thing would be good enough. Okay, let's take a look at how it represents the information right now. Okay, so let me expand this and we see that it is working. So when it clicks on this, okay, so it takes in a query, which is the list of cells that are unknown, and a value, which is the list of mines, a number of mines. So like this number 4, it takes in 5, 18, 5, 19, 5, 20, 6, 18, 7, 18, which is correct. Okay, next up we have this uh, 2, which is 5, 19, 5, 20, 5, 21. Actually, all these are good. We don't have a case of a singleton yet. Okay, so we cannot really test the logic of this. Okay, but I'm pretty sure it would work actually. So let's just code out the rest and we see whether this actually works out. I wonder if this is Euler's desktop, Netscape, my base case. But okay, let's must be really old school to use this PC. Yeah, I mean it's not too long ago that we used Windows Windows 3 or something. Yeah, Windows 4. Yeah. Back then, no, I think it was called Windows 95. Yeah, there was no 1, 2, 3. It's only after 95 and Windows 98, Windows 2000, Windows. Then it became 5, 6, 7, 8, 9. I think. Yeah, not too sure when did Windows stop using the year for their version updates. Now it's Windows 11, is it? Yeah, I don't know. I use a Mac, so not too familiar. But yeah, this looks like 95. Oh, so old now. 95. It's 20 over years ago. Okay, so let's look at this. Find out which cells are safe and add to playlist. So I did already add in this to playlist here and the no playlist. So these two steps can be deleted. Okay, this is the tough one. Look through logic array. If there's a subset of another subset, then you can remove from the main set. Okay, so it's like this. If you have A, B, C, and we already know A, B is 1, okay, then we can remove subset from the main set. I think don't need to form another logic. We can just remove because we don't need to know ABC is 2 anymore. This AB information is encoded here. So the only information we need to encode is just the C is 1. So let's try to do this. So we do the same thing for I in range length logic. Okay, um, we look through this logic array and then we see whether we can have any subsets. Okay, so how do we check whether a list is a subset of another? One way is to convert the list into a set and then to check whether it is a subset. Another way is just to like look through each element of the first list and then check whether there's an element in the second list. So that's not too sure how like subset method subset. Yeah, maybe you can just use is subset. I'm not sure how is subset does it. What's the time complexity of is subset? But it's like A dot is subset B. Okay, let's just use the is subset. Uh, I think is subset. I'm actually quite curious. What's the time complexity of this? Time complexity of is set. See, the worst case runtime is ON. Oh, that's pretty fast. Yeah, it's pretty fast. Okay, yeah. Okay, so we have this Gryffindor's dot is subset Hogwarts. How does it work though? I mean, ON is pretty fast for comparing two lists. Ah, oh my gosh, what's this? They didn't explain why. Okay, let's see the explanation. Given that A is length A, B is length B, A greater equals to B, what's the complexity of Python's is subset function? Okay, so what they do is length self greater than other, return false. Oh, I don't understand this, but I filter false other dot data dot contains. So, okay, look at this. Well, E in self dot dig dot key. If E not in other, return false. So actually, it's still two loops, right? O n square, right? Yeah. Also, they use a hashing. They use a hashing for each subset. Yeah. So hashing really helps to improve to make like an ON become an O1 lookup. Yeah. So probably they use hashing, and I kind of like Python's hashing. They also use hashing for dictionaries. Let's use the Python is subset method then. Okay, maybe we can just put like that for query value in logic. Okay, we actually need to look through the logic array twice. Okay, because we want to check whether something is a subset of another. So so maybe I'll just define this. Maybe we don't call it like is subset. We just call it subset. Okay. Uh, this returns whether a list is entirely composed under another, entirely contained under another. A equals to set list one. Okay, we can do like that. A B equals to set list one, set list two. Okay, okay. If okay, I also want to return and returns the the non-subset list because we still need to like update the list later. So if A dot is subset B, okay, so we want to take the another set method, which is like I think we can just use A minus B for sets. Is disjoints maybe difference, maybe the difference method for the set. Yeah, I do want to like take like the difference. Yes, we want the difference. Yeah, so A dot difference B is equivalent to A minus B. A dot difference B is A minus B. A minus always C. Okay, so it's A B D. B is a G F minus C. So it's yeah. So in sets, the ordering doesn't matter. So that's why the output is like BAD, although here's ABCD. So I guess in sets in Python, they probably use a hash function. and that's why there's no order preservation. It's just basically the element that you put in, they pass it through a hash function, and then they just compare whether the hash function is in another side. Yeah. So if A is in a subset of B, okay, then what we'll do is return true, okay, and then we return A minus B, or rather B minus A, okay, because we want to take the bigger set. List 2 is the bigger set, and we subtract the first set. Yeah. So yeah, we can do that. I'm just thinking whether I should sort my logic first so that I always have the smaller sets appearing at the front. I think that actually makes sense. So we can actually do the subset method faster. Okay, let's see whether we need to do it. We see whether we run out of time first. So else was none. Okay, yeah. Returns true a boolean of returns whether list one is subset of list two. This is a boolean, and then the remaining elements after removing list one from list two. Kind of need to like that. Yeah. Okay. So we have a subset method. Maybe it'll be better if I were to just like use the set um, data structure to begin with for my query. Okay. Yeah. I mean, I can do len append for set. I think you have to change it to add instead of append, but I guess I can use the set first. But I think there's no need to change it. We can just convert it to a set and do the operation here. This problem shouldn't be too hard. It's not a very big problem. But of course, if you want to optimize it, we shouldn't be using Python. Should be using like C++ maybe. Python is a slow language. Okay, so for query value in logic, okay, so what I want to do is I want to just check whether or not uh, okay, so I have this thing here, first loop. So we do a double loop. Okay, so basically we just check. Okay, okay, so actually what would be better is like that. Maybe I in range lang logic, and then for j in range lang logic, like that. Yeah. One, two, so that we don't like do the elements before. So it's a double for loop. Yeah, so this is on squared. Okay, so what we will have this is we will have element. Okay, if okay subset. Okay, so what we have is like this. Maybe we just have we call it a boolean bool. That's not quite bool. We just call it sub, and sub list equals to subset logic I 0, logic I, logic j 0, which is the queries. So we take the queries in. Okay, if sub is true, okay, that means if it's a subset, okay, what we'll do is logic j will be the subset, right? So we will just basically put logic j. This is great because if we look over the index, we are not looping over the data structure itself. So when we change the things, it doesn't change the index. So that's great. So logic j equals to sub list. So we change this to the new list, okay? And then what we also need to do is j1 minus equals to logic I1. which is the value. Okay. Yeah, I think that's it actually. I don't quite like to I'm looking at step 4 now. I don't quite like to randomly pick one. Maybe I just pick the first cell in the list. So maybe what we'll do is to play, not play. Okay, so what we can do is we can do this. Tells us which cells are still available to click. So what we'll do is like this. Okay, we'll have avail cells equals to ij for I in range 16 for j in range 30. Yeah, that will do. So then for each cell we open here, okay, if row cell not in has open, okay, has open to dot append this, and then what we'll then do is we'll take out the thing from avail cells dot remove, okay, row -1, column -1. Yeah, we'll remove this element. Sorry, they are in this one too. What do you mean by that? Uh, I'm just taking out the available cells to click, okay, by this method here. Just remove it when basically we have opened some cells. Okay, we'll remove the cell. Actually, we don't really need the has open because the avail cells will already tell us. So if row column, yeah, we can just do this. We can remove has open because avail cells would be the thing already. Okay, we remove the avail cells by this. Okay, and then not play is not defined. Yeah, yeah. So we already know that this cell is a one, so we can remove it. Actually, should I have a separate cell called not play so that I can actually know like which ones are mines? I guess I need to store the mines somewhere so that like I know that those are mines. I'm just thinking whether I should like okay, maybe what I would do here is like that. If value, yeah, we can do this. Yeah, so we can keep our singletons to be. Maybe I can keep my singletons like everything here. Okay, so what I'll do is like basically I'll just keep my singleton. So I only update my singleton with like values that have not been updated before. Okay. And actually this structure is not very efficient because I'm using a tuple. Actually what I can do is the singleton could be an array where we have an or a dictionary where the index is this cell and the output is this value. Yeah, it could be a dictionary as well. Okay, so we have this for each of this in the singleton. If query in this, remove. Okay, so all this don't change. Keep only logic values with length greater than one. Okay, right. So over here, if there's an element in the to play list, we play the first one. So if length to play added here, right? The to play, the singleton will just store the value there forever. Okay, because we want the singleton to be, we want to update our query list with all the singletons all the time. So if length to play is greater than 1, greater than 0, okay, so what we'll do is to play dot pop 0, and then we'll basically have these two numbers here, and else, okay, next play equals to avail cells dot pop 0. Yeah, something like this. Yeah, and then remove this, and then here, and then over here what we do is we print out like xy equals to next play, print xy. Okay, let's see whether this works. Okay, I hit a mine. Okay, so yeah, I guess we don't know for sure which is the cells that are like having mines, right? Yeah, it's gonna be like stochastic. Try again. Yeah, so over here we have two, but we don't know for sure which one it is. But yeah, this randomized case, is it always going to be the same? Yeah, it looks like the strategy of going from the sides is not exactly a good one. So what we'll do is we'll actually sort the, we can actually make ourselves uh, better by like sorting the avail cells method by the number of potential reviews possible. Yeah, so like maybe, how do I put it? We want to open stuff from the center if, as far as possible, so that we don't have this kind of issues where we like open from the side then everything's uncertain. Like over here 2222, can we deduce anything? Actually see over here we have this 0313 is 2, right? So actually this is already, it means it's certain already, right? So like here 0313 is 2. Just from this alone we can already tell this 2 is 2. So this is not accounted for right now in our system here. So what we can do is we can, okay, we do need to remove like more than one element now. So see over here, this is a certain case. This one is a certain case. We shouldn't be opening this. Yeah, we need to factor in these cases as well. Okay, let's see how to do it. Um, look through logic array. Okay, maybe over here. If so over here these are for singletons. Okay, if let's say okay, maybe I'm just thinking whether I should put this logic in step 2 or step 3. Looks like step 2 is the better one. Okay, maybe over here, like here. Also remove cells that have. I do think I need to keep the list of cells actually that have mines. So maybe I will preserve my not play. Okay, then over here in the original part here. Okay, so if grid cell is not equals question mark, okay. I mean it's unknown. Okay, if grid if it's in not play, okay, then what we do if is okay, num minus equals to 1. Okay, if it is for certain not a mine, no need to edit. Okay, something like that. Yep. Now we query.append. Yep, something like that. Yeah. So if it's for certain a mine, then don't edit, but we decrease the number of mines because we know that's a mine. If it's for certain not a mine, then don't need to edit. Okay, yeah, that sounds good. Okay, so then we can then look through this array here and remove element in. Also remove groups of cells if the total length equals to value, means all mines. Okay, so what we do is like that. Yeah, maybe we don't need the singleton thing because we can just look through the to play and not play list. So yeah, let's try to do this. Okay, so if this is not into play, then if not, if and then remove it from available cells. Okay, okay, something like that. Aleph len query, okay, equals to value, means all the cells are mines. for each inquiry. Okay, so actually we can condense all this into the next loop. Yeah. If the cell is safe, then you can play it. If the cells are mines, okay, means all cells are safe. Okay, so over here we can have this. If the value is 0, actually we can just do this. Yeah, means all cells are safe. Okay, for each inquiry, if each not into play, okay, or append each. Okay, good. Elif, to play list unknown. Isn't it here? To play. Oh, like that. Yes, yes, like that. Yeah, so we change this a bit. So remove element in logic array if it is certain that all are safe or all are mines. Value equals to length of query. If all cells are safe, it's 0. If all cells are mines, then it's this. And then for all of this, okay, so what we'll do is like that. For each into play, I guess we need to have a list of cells that are safe. Mm, yeah, should be fine. I think we can just put S to play. So like for okay, for each in not play, we just need to remove the one and we subtract by 1. Okay, that would be good. And then we keep only the queries with length greater equals to 1. Okay, good. Okay, again over here this tree is supposed to be a certain thing, but somehow it's not recording correctly. So let's see the issue. Okay, so over here we have like this 0, 0, 0, 0, which is weird because like over here you see 0, 2, 1, 2 is 1. Yeah, so from here you can tell that like 2, 2 is 1 because of this 2 here. 2, 2 is this one. Yeah, it should be 1. Uh, should be 0 actually. Yeah, because that means the mines are here. 1, 2, 2, 2, 2, 3 is 1, 2, 2, 2, 3, 2 is 1. Yeah. 4041 is 1. Yeah, so actually we can deduce quite a lot of things here, but over here become all zeros. So somewhere the logic didn't work out. Let's try to refine this logic. Okay, so we have this. Yeah, this actually is very hard for a medium problem. I would say this is more like hard. Yeah, because medium problems typically can be solved in about half an hour for me. Yeah, this puzzle is a little tough. Yeah. But let's try to figure out what's wrong with the logic. Okay, so I think I removed too much. So like I look through my logic array here. Remove elements in logic array if it is certain that all are safe or all are mines. Okay, that makes sense to me. Yep. Maybe what I need to do is I need to print out my to play and yes, print my to play and my not play so that I can see like what did the code do these two arrays. Let's try. Yeah, why is it all nothing? Okay, I mean, why is it? You see over here, this is correct. This thing is correct. Okay, but the logic thing itself, when I switch to this over here, somehow it removed too much. And this should be removed actually, because like if length query is greater than 0, this should be removed. Let's try again. There must be something wrong with the code. Yeah, there must be something wrong with the code here. Not play is 40. Is that correct? Yes, at least it got the 40 correct. Like over here, this one. In fact, actually 4-1 should be a not play as well. Yeah, not sure why that didn't appear. Oh, okay. This should be each, not query 0. Okay, let's try again. I survived longer this time. Okay, something went wrong here. So we do have a list of outputs here. 0, 2, 1, 2 is 1. Okay, that's correct. Okay, I'm just curious why is there like the not play and to play, or is already taken into account. So the not play is 1, 2. Okay, 2, 2. Okay, I mean, makes sense. I mean, because if this is a 2, it means that 6, 0, 6, 1. Yeah, okay. Yeah, I got the not play right. Okay, but somehow there's this issue here whereby you see the 1, 2, 2, 2, it should be a not play because yeah, over here, this one, 1, 2, 2, 2, 2. This 2 here made this 2 marked as mines already. So this is correct. 2, 2 is 1. This 1 here already marked this as a mine. Yes. 2, 2, 2, 3, 1. So 2, 2 is here. 2, 3 is here. So it should be when we remove away 2, 2, because 2, 2 is not a mine, it's already a not play. We should get 2, 3 as 0. And then hence we can put 2, 3 in the safe list. So actually with this board, we can do a lot more. So something's wrong with the code here. So we can mark 2, 3 as safe already with this starting position. So the not play is correct, but we can get more by putting some of them into the to play list. okay, which is not happening here. Okay, I need to figure out why I get this first. Okay, because like this is quite worrying. Okay, where did I print this out? It means that this part here, the logic itself with this query value is wrong. So maybe let's print out the query value here. Yeah, maybe this is the reason why it broke down. This part here didn't get printed out correctly. Okay, that's weird. Okay, because you see over here we did print it out correctly. Okay, and the logic append this. Once we print out logic, we print out a list of blanks. Okay, the blank is only for the front part. So this blank here should not be kept actually. This part should be removed actually. So I think what we need to do is we need to do this twice. Okay, that solved the problem of the, so it means that this query here is correct. Okay, okay, maybe what I want to do is I want to print out the logic after running through this array. Maybe we print out the logic twice, once at the beginning and once at the end. So we print out the logic before we do this operation, and we print the logic array after we do the operation. And then we see what's wrong with the operation. Okay, so here we have this 0212 as 1, 12 021222, which is this one, 021222 as 1. Yes, that's correct. 122223, yep, that's 1. 4041 as 1. 4041, yes. 2232 404142 as 1. This one, 2232404142 as 1. This one here. Okay, that's correct. All of them are correct. Okay, and then after we do our operations, we do not get anything else. Okay, so this is actually okay because it means that none of this are. Okay, can I get another scenario to see this? Okay, so let's see what's wrong now. Okay, 05151. Okay, 20211. Okay, 202122 is 1. Yep. 212223 is 1. Okay. 222324 is 1. Yep. Okay. 0515232425 is 2. Okay, so actually all these are irreducible because this is something that can't really be solved. And then I did 06 after that. Oh, actually I realized something. This should be YX. So over here we have like a couple of twos, but we cannot solve anything. Is it true? there's a lot of repeat though. Like over here, 202122. Yeah, I guess all of them are not solvable. Okay, let's try again. I want to see a case whereby the not solved and the solved are okay. Okay, my list of logic was this amount here, and then the next part it became nothing. My logic was empty. I think there's something wrong with this. So over here, I should. Oh, I actually reduce. Okay, so we have stuff like this. That's 200. This one, yeah. So I'm supposed to get 20 as my to play, right? Okay, so here 20 is 0. So in my to play, actually, I'm supposed to add it in. Maybe I need to do this step twice. And then at the end of this step, I will just remove so that we can iterate it over a few times. Yeah, I in range then logic. Remove cells that are certain 0 or 1. Okay, let's try again. Okay, here is irreducible. Okay, it's understandable, but wow, wow, this is harder than I thought it would be. Maybe the is subset method is wrong. Just take away the subset one first. Okay, we don't do the subset. We just do the removing part, the first part only. Okay, looks like without the subset it works better. So maybe the subset part has some issues. Why is my to play forever empty? Okay, we don't need this because avail cells will be updated here already. Okay, so what we need to do maybe is, okay, I just want to pop randomly to see what that thing is. Python. Yeah, there's some issue right now. So pop a random element from list, random.ran in. Okay, we just randomly pop because right now it's like, okay, there must be some way to optimize this, but can't change. Okay, so yeah, this Minesweeper is actually tough because like you won't be able to solve it on all tries. It's not deterministic, you see. Like there's an element of luck here. You need to submit a few times in order to solve it, but we definitely don't want to just. I just want to see whether there's a two playlist. Not play is this. Not play is 0818. Let's see whether is that correct. Yeah, that's correct. There's nothing in the two playlists. Like here's six. Okay, let's try again. I mean, at least I think it is doing well. Okay, so we have a lot of not play here. Let's see whether it's correct. 13, 11, 13, 12. That's correct because of this two, this five over here. 13, 13, 14, 13, 15, 13. It's five. This two here. Actually, once we have these two as mines already, we should be able to tell all these three as a two play. Yeah, so I think I need to refine my I think I have to refine my to play criteria in order to better like learn from what can be played. So like over here, like this two over here, I wonder what happened to. Okay, let's just track this two here. Okay, we need to see what happened to this. So this two here was given as 9, 13, 9, 14, 9, 15. So something went wrong with that. So I'm supposed to get some information from that. So 9, 13, 9, 14, 9, 15. 9 13, 9 14, 9 15, and this one, right? 9 13, 9 14, 9 15, and 13 10, 13 11. These two. So over here to play is 13 10, okay, because like you had a zero there, I suppose. Then over here, what happened to it? 13 15 9, 14 9, 13 9, 13 10, 11, 13 10, and 13 11. I only get this now. I play the next one. Yeah, something is wrong with my two playlists because like you see, if let's say this is 1 2 3 4 5, this is already a 5. Okay, I'm supposed to know that these three cells here, because of this two, these three cells are supposed to be playable because of the way Minesweeper works. So I need to debug this, like because this is a very clear cut case where you open up, you see 5 mines. I mean, at least the not playlist is updated correctly. We already updated this as 5 mines. Okay, we have a to play as 1310. Okay, that's correct. But we should also have to play as this two also. So I have a feeling that I did not update my to play correctly. So like over here, if value is 0, how did I lose so much information? Like I only end up with two Boolean logic. What happened to the rest? Remove all the cells that are mines. Not play dot append each. Yeah, this to play method. Something's wrong here. I mean, something's wrong here. Yeah, I'm not supposed to reduce my logic so fast. Let's remove this line. Aha, see now I have a much bigger to playlist. Oops, oops. So something went wrong with the filtering, I think. Okay, at least now I know what's the issue here. I know what's the issue. This removal operation removes too many queries. Maybe I do this, see whether it works. Okay, it looks like the length greater than 0 1 was, because I guess this one could mean length greater than 0. I'm not sure. Yeah. Okay. So looks like there's some improvement. So we have a to play list. So we can put the to play here. Okay, maybe what we'll do is we'll also print out the not playlist over here, like print mines equals to, maybe we have this print mines as like that, print mines plus equals to AB in not play AB EA. Yeah, let's try this so that we can like pin the mines in the Minesweeper. Yeah. Okay, let's see. Okay, it's not exactly. I thought I would be able to pin it. Oh, okay, because I put in brackets, so I need to do like that. Okay, here we don't have any mines, so it's fine. Okay, here we mark this as a mine. That's great. Okay, good. We got all this as mines. Good. Okay, looks like it's working. But now once my to play list is gone, it will start guessing randomly and it might die quite easily. So we need to optimize the way to select cells. Okay, let's just return back this logic of the subset one. See whether it helps a bit. Let's try this. Maybe in fact we might also want to loop this a few times or so. Okay, it looks good. Okay, so I think this is decent performance so far. We already know that these are marked. Okay, maybe what we'll do is if some cell is uncertain, okay, maybe we want to not do it. But first, let me just maybe, I don't know, if you iterate this more times, will it help? Let's just try. Okay, let's just try. Just do our for loop like multiple times to see whether it works. Yeah, see whether it makes it more robust. How long did I survive for? I died quite fast. Okay, this is because we are not too sure what to play next. Okay, I can accept that. I can accept that because it is in fact quite a. It's playing quite well actually. Yeah. Yeah, it is doing a decent job. Okay, now it doesn't have anything to count on, so that's why. Okay, so over here we do have to make some guesses because like we don't have much to rely on. Like over here, 1 and 2, we don't really know what's the mines. But I think overall the algorithm is doing quite well. I think like even this, I think the sub list is there also. Oh, but what happened to my list over here? See, I had quite a number of variables, but suddenly the whole thing became empty. So there's something wrong here. Like I do want to store, so although it's playing decent, like over here everything disappeared, which is very weird. Like I mean, yes, I take away this, but why is everything like, oh okay, because yes, already been mapped out. But you see, there's some things that are not solved yet. There are some things that are still like dubious, like still not too sure what it is. You can't just cancel them out like that. Over here became nothing already. So there's something wrong with this. Even before I do this part here, I would like to solve that thing because it is not exactly doing the logic right, I would say. I mean, there should be still some like instances of, yeah, there should be some query left. So it's the subset thing that is causing it, right? Well, this survived quite long. Even without the subset thing, it's working pretty well, I would say. Oh, it's actually progressing quite well. It's progressing quite well, actually. Yeah. Actually, since we already know this tree here has a mine in these two squares, then it can be said that all these here are safe by right. Yeah, so we actually do have some information here. Yeah, so maybe that's the subset part that we need to encode in. Okay, because this tree encodes this part here, we already know that this two is there. So actually we can see over here, like 1522, 1523, 1. I think the subset thing is the one that is not implemented correctly. Once we implement this correctly, we should be able to get it to work quite a lot. Yeah, I'm gonna see what's this sub list here. Okay, I have a feeling this sub list is faulty. Yeah, what happened to all my queries? All my, say, hang on, I found something. Stop. Okay, my sub list is here. So like I do have a few lists here. 3, 12, 4, 12. 2, 12. Okay, 3, 12, 4, 12, 5, 12. Okay, so there's some issue here. Okay, this should be range I plus 1 actually. Now I know why this doesn't work. Because like it kind of deletes itself because it compares with itself and then determines that it's a sublist. Okay, and actually we need to have one more condition for sublists actually in the sublist here. Okay, and length A smaller than length B. We want it to be a strict subset. We don't want it to just be a subset. We want it to be a strict subset. So like we want one to be bigger than the other. If not, one set would completely cancel out the other, which is not what we want. Okay, let's try it out now. Okay, now this looks decent. This looks decent really. Yeah. How long did I survive for? 250 steps. Not bad. We are almost there already actually. Yeah, it means that we are almost going to solve this game. We can. Actually, maybe if we try enough times, we might be able to solve it already. I can delete away this here. Okay, let's try again. Okay, like you see over here, this five, right? One, two, one, two. It means that this four inside one of them is a mine. Like here, three, one, two. Yeah, we could actually do like mine probabilities to just based on the numbers that we see here. What are the probabilities that you will pick a mine? So we can actually pick the square that has the least chance. Okay, but before that, let's just ramp this up a little. We'll just do until 10 iterations each. Because the more iterations you do, actually the more in-depth your search algorithm actually checks. Okay, so let's see whether ramping up helps. Okay, so this became 10 only, not grades. Okay, that may be just the nature of like of the grid. Okay, I do think that we are almost getting there already. We are almost there already. Like over here, you see, what can my AI do? Like here is three and here is one. I mean, we have to open up the grid somehow. One, two is either here. Three, one, two, three. Actually, this is certain, right? Isn't it? Three. This two should be certain. Why is this not in the not play list? I think I know why. Okay, if let's say I actually open up the new rows here, right? I supposed to uh remove those cells already. So Okay, so what we need to do is maybe we have like newly open. Let's bring back our newly open array. So like over here, this tree here with this open. Okay, I should already know these two are mines. Okay, so newly open is this. So what we need to do is okay, we have a newly open here, and then over here in the newly open we remove this. Okay, let's try again. Remove those cell positions that are already open. Then we do that for all the newly open. Okay, because we will not need. Oh, soft, soft. Oh, finally. Oh, this is so hard. This. Okay, try again. Okay, so sometimes it works, sometimes it doesn't. But it does seem that this is quite competent already. Okay, like how far did it go? It went quite far. It went to 229. So one way to improve the algorithm is to like guess smarter. Like let's see where it failed. Yeah, but this stochastic, so it takes a while to. Okay, where did I fail? Okay, okay, two over here. So where did it put? Okay, so like over here two, here is four. One, two, three, four. So it's either these two. So three, one, two is one of this. Three, one. Yeah. So one way to do this better would be to like let it um like guess the mine smarter by using some probabilities of the mines. Yeah. But or if not, we could just like keep submitting and see whether it works. Yeah. I mean, you need to be a little lucky. Because like once you reach cases like this, there's no way to find out where the mines are already. It's like luck already. Yeah, let's just submit this and we just hope our luck is good. I'll submit this 10 times and then we see whether we can like solve it in one of the 10 times. Yeah, I don't really like problems that are like stochastic. Okay, let's try again. Like over here, 333. Now we wouldn't know for sure which one it is. Maybe we could have a way to play smarter here. Like instead of using random, we basically pick one whereby like it is lower chance to have a mine, I guess. Yeah. So um, let's just try submitting a few more times to see how it goes. Yeah, but it did work for one grid, so it means that the logic is around there. It's about there. Okay, let's try again. Oh no, they asking me to prove I'm not a robot already. But it did work for one, so I treat it as soft. Yeah. Oh no, makes the max summation is a row. Okay, guess I'll try this again in my free time. I just need to submit this a few more times, and I think it's more or less working already. This took quite long to solve. Okay, but the idea was basically to just have a series of logic, and then like you see over here, and basically just find out which cells are safe and which cells are mines. Okay, if the length of your query, which is like the list of cells, equals to that number, it means all are mines. If it's all equals to 0, okay, it means that all are safe. So you can put the safe to play and the mines to avail. And then for those in to play and avail, which are for certain, you can remove them. Okay, and then like for stuff that's newly open, you can also remove them. And yeah, basically this is uh, the whole game loop. And after that, we also can remove subsets like A, B is 1. We can remove that. We can get C is 1. And yeah, we can do that multiple times as well for the subsets. Okay. Uh, yeah. Actually, I realized something. We should sort our logic by length. If not, some subsets will not be removed. So maybe we can do like logic dot sorts key equals to, yeah, maybe let's do one more thing before I end. So in the sort function, yeah, we can sort by length. Okay, so lambda x. Okay, yeah, we sort by the query length so that this subset thing would make more sense because we only take the first one and then we check all the back for the subsets. Okay, so this indeed is a big improvement. It managed to like, so the shorter length query should be at the front, the longer length query should be at the back. Let's see whether this is true. Yeah, it looks like it's correct. The longer length query should be all at the back. Okay, so it's almost solved already. Like over here, you have to just make some guesses. Yeah, I guess next up I could do a function whereby based on probability I choose the cell that has the least chance of having a mine, and that might actually help it to solve better. I mean, after all, it's stochastic, so yeah, it's stochastic. So we need to minimize our chance of hitting a mine. Right now, I'm just doing a random press, which is random. So sometimes you hit, sometimes you don't. So in general, it reaches around 212, which is a good sign that the algorithm is smart and able to understand stuff already. Like once you reach until here, really it's just luck. Yeah, we just see, you can see that this problem, even you do until here. Maybe a more sophisticated algorithm to find out where the mines are would help. I'm not sure, but yeah, definitely this is almost there already. How will you solve this in real life if you're given this one? Like over here, this cell here has a 1/5 chance of a mine or 1/3 chance of a mine. Maybe I'll prioritize the corners first. I'm not sure, but that might be a good strategy for some cases. Let me think about this. How to solve this? I'll probably come back and stream again to solve this problem. But I think in general the logic is there. So basically you just try to find out which cells have the mines, remove them, and then keep iterating through that process. And then if like a certain subset is within another subset, you can remove that from that subset as given here. And then yeah, we just basically play the next safe move. If not, we just play a random move. So over here we can do a to do, make the move selection, select cells with least probability of mines. So that could be one thing to do. Yeah, which is why I think this is not exactly like a medium problem. This is actually quite difficult, maybe hard. Yeah, but yeah, we'll see about that next time. And see ya. Bye. Thanks for watching.